and the first problem of this rapid fire set. My predictions, by the way, for what I think the cutoff would be, top 2.5%, I'm gonna guess that the top 2.5%, which is not the same as the cutoff. If you watch my other video, you should know that, the one right before the test. I'm thinking it's right around 111 to 114, something in that range. Maybe 112.5, I think that's a possible score as well. So I think it's right around there. That's my gut feeling after taking the test myself. And then after that, what's the actual cutoff prediction? The actual cutoff prediction would probably be 105 or 106.5. That's my guess. Okay, this is a guess. Don't know. If you're looking for AMC 12, I don't have any clue right now. All right, gonna move on. So back to this problem. If you did the test last year, you probably remember a certain problem that had absolute value with a square root of this. And if you don't know, the square root of something squared is the absolute value of that thing, whatever it happens to be. Even if it's a binomial expression, so you're going to get this. You're going to get a minus 2 minus the absolute value of a minus 1. Now we get to the same thing I said last year on problem 2. I think it was on the B test. The absolute value of a minus b is equal to one of two things. It will be a minus b if a is greater than or equal to b. It will be b minus a if a is less than b. In other words, if a is less than b, what we mean by that is this is negative inside. A minus b is negative, so you flip it. For example, 4 minus 7 is equal to 7 minus 4. Because it's an absolute value, it gets flipped when it was negative. So now we think a is less than 0. That means I've got a negative minus the negative. That means you're going to flip it. And so it's going to be absolute value of a minus 2 minus, you're going to flip the a minus 1 to 1 minus a. Now you're going to have absolute value a minus 2 minus 1 plus 2a. Yes. And then that's going to be, oh, hold on, something's not right. Not plus 2a. Whoops, there's no 2. Okay, there we go. Plus a. There we are. And now we're ready. So for some reason I saw this 2 and I thought I was distributing. It's been a long day. So then a plus a is 2a minus 3 in absolute value, keep in mind. Again, a is negative. A is less than 0. This is a negative expression, just like the bottom version here, which means you're going to flip it. And so you're going to get 3 minus 2a. Pretty standard fare considering last year's question. On to the next one. Let's continue on. This is going to be the 2022 AMC 10A problem 7. It was also the 12A problem 4. The least common multiple of a positive integer n and 18 is 180. So a common shorthand notation is brackets for LCM. We want that to equal 180. And the greatest common divisor of n and 45, again, a common notation is parentheses, is 15. So this is just used in the AOPS books a lot. I picked it up from there. It's useful. What is the sum of the digits of n? So basically find n and then add up its digits. There's two ways you can approach this. One's going to be more formal, technical, definitive, and one's going to be kind of logic. The logical one would look something like this. If their greatest common divisor is 15, okay, so I'll put this here for your help, then that means n's got to be a multiple of 15, right? And so if you try 15 and then do it with 18, 15 and 18 will not have the 180. And then if you try 30 and then you go through like that, right? You could make n 45 and so on. You could just guess it out until you find one that also works in here and then go, using multiples of 15. So here's the more formal way you'd probably be doing it and feel, I don't know, a little bit more like you're doing it like you're supposed to. So for the least, I have a saying, for the least you want the greatest, and for the greatest you want the least. What does that mean? Well, 18 is 3 squared times 2. And we don't know what n is, but we know that for the least, you would want the greatest, and 18 over here times 2 times 5 is going to be 3 squared, 2 squared times 3 squared, I'll put it in reverse order like I did the other one, times 5. And just to verify, 36 times 5 is 180. So then, if for the least you want the greatest, what that means, oh, that's n, oops, wrong spot. Let's put it here, 3 squared times 2 squared times 5. What that means for the least you want the greatest is for the least common multiple, you want the greatest power you can choose, okay? So if I've got 3 squared, n does, at least in this case, it does not have to have any 3's. But if it did, they would not go over 2. What it does have to have is 2 squared, because this one's only got 1, 2. That's not the greatest because there's a 2 squared in the greatest. So this one must have a 2 squared. It can also not have 2 to the third, because if it had 2 to the third, that would be the greatest, and you would see a 2 to the third in here. Okay, there's no 5 in 18, so n's going to have to contribute that 5 as well. And then after that, we know the only other values we could have would be potentially 3 to some power. Okay, so far we have got 20, and then, yeah, times 3 to some power, maybe 0, could just be that. So then you're going to have that. Now, when we do the greatest common divisor, I say for the greatest, you want the least power available. And since 15 is 3 to the first times 5 to the first, but we're doing it with 45 now, so if I check 45, it is equal to 3 squared times 5 to the first. Well, if 3 to the first is the least power available, n's going to have a 3 to the first in it, because the 45 that it's working with has 3 squared. So that means we've got to have a 3 to the first, which is the least power between 3 to the first and 3 to the second. Okay, so then what? That means we've got here, the 5 to the first was already in n, and it's in 45, so no issues there. Everything looks good. Let's just make sure that this, and again, this could have been any power of 3 up until 2 for it to work with the LCM. And this is going to be it. N is this number. 4 times 5 is 20 times 3 is 60. Add 6 plus 0 to get 6. Let's get on to the next problem. So continuing on now with the 2022 AMC 10A problem 8. It was also the 12A problem 6. A data set consists of 6 not distinct positive integers, 17525 and x. The average arithmetic mean of the 6 numbers equals a value in the data set. What is the sum of all possible values of x? By the way, we're going to talk about sillies in the future, but right here equals a value in the data set. My brain went, don't forget the x. And so if you forgot that, there is a wonderful trap answer waiting for you. We'll discover that in just a moment. Let's get on to what this is. If I want the average of 6 things, you want to add them up and divide by 6. So I've got 10, 9 and 1 is another 10. I've got 20 plus x over 6 needs to equal, and you're just going to find a way to set this up, right? So you know that you're multiplying by 6 each time. So for instance, let's say I set it equal to 1. Then you're going to have the calculation 20 plus x equals 6. This is a test as well. The algorithmic process by which you solve can pay huge dividends on your time savings. So right here at this point, when I was doing the problems on my own, I immediately just started multiplying all the values. I went 1, 7, 5, 2, x, and I'm going to multiply all of them by 6. So I'm going to put equals 42 equals 30 equals 12 equals 6x. Then over here now, I'm going to get x equals negative 14. Here, I'm going to move the 20 over and get x equals 22. Here, I'm going to move the 20 over and get x equals 10. Here, I'm going to move it over and get x equals negative 8. The last one we'll do separate. 20 plus x equals 6x. Move the x, get 5x, get x is 4. Now, what did it say? Go back and check. This is the point you want to go and check what's there. So it consists of 6 not distinct, that's fine, there's a couple 5s, positive integers. Okay, then if x is negative, does that work? No, it does not. I am curious to see if that's also a trap answer. We'll look for it in a second. But first, let's get the actual answer. You're going to get 22 and 10 and 4. If you forgot to set it equal to x and then multiply by 6 and all that, if you forgot that, you would have got 32 waiting right there. Pretty good trap answer for you. Now, what if we had taken these two negative 8s and wiped out the 22 and forgot the negative 14 and negative 8 to wipe this out, and you forgot this 4, there would be a 10 here for you as well. I don't know how you would get the 26. Maybe if you only got the 22 and the 4, but you forgot the 10. I guess that might be it. Anyhow, the answer is 36. Be really careful about trap answers as you're going through. They are trying to trick you. Remember that, right? That's the goal, and you're trying to avoid it. Experience teaches you how to avoid mistakes. That's why a lot of people say, solve thousands of problems. Let's get on to the next one of those. Okay, so continuing now, we have the 2022 AMC 10A Problem 9. It's also the 12A Problem 7. A rectangle is partitioned into 5 regions as shown. Each region is to be painted a solid color, red, orange, yellow, blue, or green, henceforth known as A, B, C, D, and E. So that regions that touch are painted different colors, and colors can be used more than once. How many different colorings are possible? You have kind of two approaches here. One, you could do casework. So for casework, it would be something like these two could be the same or different, these two could be the same or different, and these two could be the same or different. And you could do all of the cases where like these two are the same and these two are the same. That'd be like one case. So for example, you might go A, B, B, and then C, and then A. Something like this, and you could say this is like case 1. And then case 2 would be that you keep the A's the same, but these no longer are different, or no longer are the same. So you would put like A down here, and then in the middle you'd have a D. So you've got these two the same. Then you do another one with these two the same, case 3. And you could say, for instance, if I put the A there and the A up there, and then B, and then C, and then D. And so first you have this pair the same, then you have this pair the same, then you have them both the same. Another case could be where these two are the same. So if we said C, B, and then you have A, D, and A. So now you have those two the same. And finally, case 5, all different. Basically, each one of the boxes is a different color, and you would have 5 factorial ways of doing that. So after you make the cases, it's actually not that hard this way, but it's not quite the most efficient way. We'll get to that in a moment. The next thing that you could do here then is say, okay, how many choices do I have for A? I've got 5 choices, B 4 choices, C 3 choices. So 5 times 4 times 3. On this one, it's 5 times 4 times 3 times 2, which is equivalent to 5 factorial. 5, 4, 3, 2, 5 factorial. 5, 4, 3, 2, 5 factorial. So you would then have 4 times 5 factorial plus 60, 20 times 3, and 5 factorial being 120. 4 times 120 is 480 plus 60, 540. Okay, as mentioned, casework was not required. There is going to be another opportunity you could have had at the beginning if you spotted it, and if you didn't, it's okay. Okay, when I show you the solutions, I'm generally showing you what I did to solve the problem. Even I don't always find the most efficient way. And that's just, you have to roll with that on the task. Just like any sports team doesn't always get maximum efficiency when every play that they run. Neither will you. So I'm going to give you the faster way now. This piece is kind of chairman of the board. And so you could say that you have 5 choices for this one. Once that piece is chosen, this piece must be different from that one. So I have 4 choices for that one. This one has to be different from both of those. So it has 3 choices. Now this one only has to be different from these 2. So it would again have 3 choices because you can reuse colors. And finally down here, it has to be different from these 2. It could be the same as either one of those, which is why you would again have 3 choices. If you then multiply 5 times 4 times 27, 20 times 27, 540. Pretty slick if you thought of doing it that way, but we're going to get on to the next problem. And the last problem for this rapid fire set, 2022 AMC 10A, problem 10. Daniel finds a rectangular index card and measures its diagonal to be 8 centimeters. Daniel then cuts out equal squares of side 1 centimeter at 2 opposite corners of the index card and measures the distance between the 2 closest vertices of these squares to be 4 root 2 centimeters, as shown below. So this corner to that corner, 4 root 2. What is the area of the original index card? I just have one question. Why though? Like, why is he measuring? I don't understand. Okay, but whatever. And how did you measure it to be 4 root 2 precisely? I mean, because that's not rational. I don't know. Kind of weird, All right, so one mistake you could make is assuming that this will hit the corner of the card. It will not, okay? There's no reason why it should. What we can do, though, is go ahead and come out here and close out these sides, and we'll call this dimension A and this dimension B, and we want the original area, so we're looking for A times B as our answer, okay? We do know that A squared plus B squared does have to equal 64. Thank you, Pythagoras. And next we're going to come right down here and make a right triangle right here. Now keep in mind you're losing 1 right here and 1 over here, so that dimension there, I'll draw it separate so you can see it. That dimension there is actually A minus 2. And then going down, you're losing 1 here and 1 here, so it's, oh wait, no, that one's going to be A minus 2. That's the upper. It doesn't really matter, but you get B minus 2 here. The same calculation is going to occur. You're going to do Pythagorean theorem. You're going to get A squared minus 2A plus 4 plus B squared, I'm sorry, not 2A, 4A. I'm squaring poorly right now. A squared minus 4A plus 4 plus B squared minus 4B plus 4. And this needs to equal square 4, get 16, square that, get 2, get 32. So now you'll have 32 equals, didn't we see A squared plus B squared right there? We'll grab that. We've got 64. We're going to have minus 4 times A plus B, and we're going to have plus 8. I factored out the 4 here. So I think I'm going to divide by 4 now. Before I even, well, maybe I'll move some things around. I don't know. Let's put the 4A plus B on this side. That way it becomes positive. Then I'll move the 32 over to get 32 and add 8 to get 40. Now we can divide by 4. We know that A plus B is 10. Oh, are we done yet? No, we need the product here. Well, what can we do? Well, we still have A squared plus B squared. We're going to dip right back into that pool and square this out. You're going to get A squared plus 2AB plus B squared is going to equal 10 squared, which is 100. I know those 2 are 64. Give me 64. Subtract to get 36. Divide by 2, get 18. Circle E. Get to the next problem on the test. I like to write what I'm looking for before I look for it, because then it helps at the end for processing. When I see it, I'm able to respond faster to that stimulus. Let's get to problem 11.